Hello, I'm Carl Zielinski, and today we are doing an Odin plus Raylib tutorial. In this tutorial we will create a snake game from start to finish. A snake game you might recognize from maybe some old cell phone or from some internet games you played. It's essentially a little snake going around on a grid and eating some food, and then it gets longer and longer, and you get higher score by getting a longer snake, and you get game over if you hit a wall or hit your own tail. So we will be creating this game using Odin programming language and Raylib. I have a separate video on how to set up the Odin programming language that is linked in the description, and Odin comes with built-in bindings for Raylib, so there's no extra setup needed for that. I will be using Sublime text for editing the code. I also have a separate video on how I set up Sublime text, and that video is also linked in the description. Now, if you use some other text editor, then that is completely fine. The only thing you need to be able to do is compile and run Odin program somehow, be it using a hotkey inside your editor or from the command line. For those who have followed my Sublime tutorial, I said in that tutorial that we can easily create a new Odin project by copying the project sort of template that we created in that video. So here is my code folder where I have some different projects. What I want to do here is create my Sublime project for the snake game. So I right click and choose new and folder and name it snake. And like I've said before in the other video on Sublime, is that I can create a new Sublime project by taking my template from inside my Sublime Odin folder here, copy it, and then paste it into the snake directory like this, and then I can also rename it to snake. What I will do now is just double click this, which then opens our new snake Sublime project, and I also have the core and Raylib folders here, so I can easily jump to the definition in those files. On the side here I have an outline of what we will be doing in this tutorial. So let's jump straight into it. So step 1, open a window. Like I said, we will be using Raylib here. Raylib lets you open windows, display graphics, play sound, etc. And Odin comes with built-in support for Raylib. So what we'll do here in our editor is that we will right-click the snake directory, choose new file, and we will save this file as snake.odin. And in this file, we can then write at the top package snake. All files in Odin must have a package definition at the top, and all files within one folder must use the same package name, otherwise it won't compile. And then every program on your computer has to start somewhere, and in Odin, programs start with the main procedure. So you write main : proc, some parentheses, and then some curly braces. So the program will start here, and it will end when it reaches this curly brace, and in between these two curly braces essentially goes your program. Now we want to use Raylib in here, and like I said, Odin comes with bindings, so we can just before main here write import rl, and then we write vendor : Raylib like this, and then we can use Raylib inside the main proc here. So the first thing we need to make a program do is open a window, and you do that using Raylib by typing rl.init window, and then I want it to be 1000 pixels by 1000 pixels big. So I type 1000 here and 1000 there. That's the width and the height. And then it wants the, as it says here, it wants the title of the window in the third parameter. So we type snake. These thousands here we will actually want to use in some other places in the code, so we can right away move them into a constant, and a constant is a value that you can give a name but that can never be changed. And we will put it just above the main procedure here, and we'll call it window size, and you make constants with 2 colons again like that, and we just write 1000, and then we can copy paste window size, paste it there and there. So that's the line for creating a window. Then we need to make a loop that runs for as long as this window stays open. Video games essentially consists of a series of very quickly updating frames, one after another, and these frames need to be displayed until the window closes. So essentially what we want is a loop that runs for as long as the window stays open, and inside this loop the logic and the graphics displaying and the sound playing of our game happens. So the way we do that is by typing for, and then we write exclamation mark rl.window, and then we can use the code completion if we want. You can hit control space like that, and it says window should close. We can press enter, and then after that we put some curly braces like this. So this loop will run forever until the window should close. That the window should close means that someone clicked the little button in the top right corner of the window. And the exclamation mark here means that it should do the opposite. So it should run this loop for as long as the window doesn't want to close. And whatever happens between this curly brace and this curly brace is what happens each frame of our game. And then for each frame, the first thing we will do is say rl.begin drawing. Then we will write rl.end drawing after that. And between those two lines is where you need to put all your code for drawing things onto the screen. That's where you display your graphics. We will start off by just clearing the screen with a color. So we type rl.clear background. And this, you see this one wants a color here. So we press enter, and you can choose any color here. I have figured out some colors that will play nicely with the graphics that I will introduce later also. So I will write in curly braces like this, I will write 76, 53, 83, 255. This is the red part, this is the green part, this is the blue part, and this is the transparency. So this is a fully opaque color. It's slightly red and blue, but a bit less green. And 255 is the max value for each of these. Then if this loop then stops, then we need to close the window. So then we go down here and we write rl.close window. Let's now test this program and see if it works. You might have to go into the tools menu and choose build system and choose your build system here depending on what the name of it is. But mine is already correctly set up, so I can just press F7 and then the game compiles and runs. And as we see, it's a 1000 by 1000 big window that is constantly being cleared with this color. So we can close that now. So before we move on, I just want to add one tiny thing here. I want to enable vertical sync. This means that the game will wait for the refresh rate of your monitor, so it doesn't actually update faster than your monitor can display. This will reduce the amount of noise your GPU makes, and if you're on a laptop, it won't drain your battery as quickly. So what we do is, just before the rl.init window line here, we type rl.setConfig flags, some parentheses, and then the flag for vsync is vsync hint. So that then will enable vsync. I'll just close the folder view on the side here since we don't really need it anymore. View sidebar, hide sidebar. So let's go to the second part here. Draw snake head on a grid. So these snake games usually have some kind of snake, and the front part of the snake is known as the head. And what do I mean by grid? Well, I have an illustration here of what I mean. We will split our screen up into 20 by 20 squares, where each square is 16 pixels. So we'll have 20 here, like this, and each of these squares will be 16 pixels wide and high. And our snake head will then be one of these squares on this grid. So how will we then define this 20 by 20 grid in the code? Well, we will create a constant called grid width. And constants you create, like I said, like this, just with 2 colons in between the name and the value. And then we will write cell size, which is each of these squares. How big are those? Those are 16 by 16 pixels. And then another thing we need some way to represent the snake's head position on this grid. So for example, if the snake's head is here, then this square here has some kind of coordinates. And if you start counting from the left on this axis, then it has the coordinates 0, 1, 2, 3, 4. And from the top it has 0, 1, 2. So essentially this snake head needs some kind of 2-dimensional coordinates to represent where it is in the world, one x and one y value. So the way we will represent these coordinates in Odin is using a vector. So we will make a new type, as it is called, and we'll call that type vector2i, and we write 2 colons and then some angled brackets and then int. And this means that vector2i is essentially a list of 2 integers, which means that it has 2 numbers and we need x and y. So then we can now use this vector2int type to store our snake head's position. So we make a new line here and we write snake head position is a vec2 integer. So this creates a new variable that we can change the value of, and it is of type vec2i. This is a global variable that is accessible from anywhere in our program. So inside the main procedure here, we can give it a good initial value, and the value I will give it is the following. So we type snake head position equals, and this sets the value of it. And then in order to set both the x and the y part of this number at the same time, we write these curly braces, and the first part here is the x part. So we write grid width divided by 2, and then I write grid width divided by 2 again. And since this is 20, this means that this is 10. So it will be at position x10, y10. So let's now go ahead and draw this snake head somewhere on the screen. We will do that using the draw rectangle feature in Raylib. So just after clearing the background, we will draw the snake head on top of that background. And we will need to define the rectangle on the screen, that is the snake head, just like I did in this picture essentially. So the way we define that rectangle is by writing head rect colon equals, and colon equals here both declares a new variable and then sets the value of it immediately. You saw here we create a new variable, but we don't give it a value. When we type like this, it just has the standard value of 0, 0. So x equals 0, y equals 0. And here we give it a value. And down here, we're making a new variable, but also setting the value of it at the same time. And this one will be of type rl.rectangle, which represents a rectangle that can have a x and y position, but also a width and a height. So you can type rl.rectangle like this, and then some curly braces. So between these two, you give the rectangle its initial value. And the first number we put in here is the x position. And we want to take the snake head position.x times the cell size. What this means is that since each cell is 16 by 16 pixels wide, we will then end up on the correct pixel on the screen. So if your head position is here, where the x value is 0, 1, 2, 3, 4, then the position of the rectangle is actually 16, 32, 48, 64, which is 4 times 16. Then we make a new line here and we write the y coordinate, which is similar, snake head position.y times cell size. And then the size of the rectangle itself is then just cell size. So this is the width and this is the height. Now this won't compile yet because this value here is an integer and the rectangle consists of F32s, which is decimal numbers of size 32-bit. So you must explicitly convert it from the integer to the floating point number. So it expects it to be of type F32. So we convert it by typing F32 like this and like that. And then you need to do the same for this one and this one. These are constants. They don't really have a type in that sense. So you don't need to cast them, as we say. You just need to cast or convert the type of the x and y position. Now let's draw the head rect somehow. So what we'll do is we'll type rl.drawRectangle, and now you can press Ctrl space to get some completion, because you see there's lots of different draw rectangle variations here. We want draw rectangle rec because that one just takes a rectangle and then a color. So I press enter on that, and then I send in head rect, and then for color I will just send in rl.white. You can save that and hit F7 to compile and run. If you compare this image to my sketch, then this square seems to be a bit small almost. And that's because we are having a 1000 by 1000 big window, But if you think about it, 20 squares where each one is 16 pixels wide only makes like 320 pixels, not 1000 pixels. So even if we were at the coordinate x equals 20, y equals 20, we would just end up somewhere around here where I'm wiggling the mouse. So there's some different ways you can get around this. We will use a camera to zoom up the content so that it matches the size of our grid with the size of the window. The way we will do that is by adding a new constant. Up here, just after cell size, you can type canvas underscore size colon grid width times cell size. This then will, just like I calculated before, be 20 times 16, which is 320. So we expect the sort of canvas we're drawing on to be 320 by 320, but our window size is 1000 by 1000, so we need to somehow zoom it up so that this stuff fills the entire window. And we will do that using a camera. So we'll put the camera in here just before we create a rectangle. I will write camera colon equals rl.camera2d, and a camera 2d has an offset, a rotation, a target, and a zoom. We can leave the offset, rotation, and target to their default values and only change the zoom, because we want the camera to be at target the position 0, 0. We don't want the camera to move around. We just want to use the camera to sort of zoom up the view a bit. So what we'll type here is zoom equals, and then we take the window size and we cast it to a floating point number, to a decimal number, and then we divide it by the canvas size. Now, if you were to skip this cast to F32 here, and just write like this, then it would divide 1000 by 320, but it would actually throw away the decimal part because it doesn't know yet that we want it to be a decimal number. So you would get something like 3, zoom 3, but if you keep the F32 here, then you will get some decimals. So then your zoom will be something like 3.125 or something like that, which will correctly make it fill the whole window and not just part of it. So now we just need to use this camera. So we will just below the camera definition here write rl.beginMode2d, and then begin mode 2d wants to have a camera sent in, so we just write camera like this, and then just before we stop drawing we will end mode 2d, so write rl.endMode2d. And now if we press F7 to run and play, you see that this square is now here, and this is at coordinate 1010, and that would mean that the upper left corner of this thing is in the middle of the screen, which looks very much correct. And it is good in general to note that Raylib always counts all coordinates from the top left corner. So the window has its x equals 0, y equals 0 coordinate up here, and when you give a rectangle a position, the position you give it is the position of the top left corner of the rectangle, and then the width goes this direction and the height goes downwards. So we already did step 3, zoom using camera. Now we can go to step 4, make head move. So in our game, we want the head to move at even intervals of time. The program runs very quickly. We have VSync on, but it will still run at like 60 frames per second on this computer. And we don't want the snake head to move 60 times a second, because we want it to be here, and then maybe a bit later we want it to be here, and then want it to be here, etc. We do not want it to just fly across the screen in the blink of a second. So we go up here and we need to define some kind of timer for how long it should be between the movements of the head of the snake. And we need to first write that number down. So we will make a constant called tick_rate, and we will give this the value 0.13. So that's 0.13 seconds. That's how long it would be between each movement. And then we need a timer variable that contains how long is it until we should move. And that I will call tick timer. So note here, this is a constant because it won't update, but this needs to be a variable. So I will give it a type f32, and I will set the initial value to tick rate, so that the first tick will take 0.13 seconds. So now we can use our timer down here in the loop, and what we'll do is each frame, the first thing that happens here is that you take the tick timer and you decrease it by rl.getFrameTime. rl.getFrameTime tells you how long did the last frame of the game take. And the game essentially measures these between how long has it taken since between one end drawing call and the other. So Raylib saves that info somewhere and lets you use it. So this will then decrease by this number, and this number might be something tiny like 0.016 or something. So it will take a few frames for tick timer to go close to 0, which is when the snake head should move. So this means that we can write here if tick timer is less or equals to 0, and then we put some curly braces. So this is when the tick timer has reached 0 or is less than it, because it might overshoot a tiny bit. Then this is where we want to move the snake head. So I will write snake head position plus equals, and we will just hard code in a number here, but we'll soon make it so that you control it using the arrow keys. So I will write 0,1. This means that it will move 1 square down on the screen. And then we need to make sure that the timer starts over from 0.13 again. And the way we do that is by writing tick timer equals tick rate. One thing you can add here is also to add on the tick timer itself, because if you just write this, then the tick timer might have overshot, so it's like minus 0.01 seconds or something here. And if you just set it to tick rate, you can essentially lose some time there. So since the tick timer is guaranteed to be 0 or less than 0 here, and if it's less than 0, then you should actually remove some of that time from the next tick frame, which means that this will be 0.13 plus this negative number, so it will be slightly less than 0.13. So if we now hit F7 to compile and run, then we see that the head moved off the screen and disappeared forever. We can run it again. So what we want to do now is make it so that we can control the direction of where it is moving. We essentially want to control this thingy here we add on. So what we did here, by the way, is that we added two vectors together. So this is a vector to integer, and you can add them just like you can add normal numbers. So this will be added to the X part and this will be added to the Y part. That's why it moved downwards on the screen, because positive Y is downwards on the screen in Raylib. So what we will do is we'll introduce something called move direction, which is another variable up here. So we'll just group these together, and just below here I will type move direction is a vec2 integer. And then just below snakehead position here I can write move direction equals 0,1. So it has the initial value of 0,1, and then down here, instead of adding this thing, I can just add move direction. Now if I compile and run this, the exact same thing happens. So let's now add input so that we can control the move direction, so we can move this white thing around. And after we've done that, of course, you've seen that we only have one square that is the head. We will introduce multiple body parts so that the snake actually is not just a single square after that. But now we will add some input. So just at the top of the main loop here, we will write if rl.IsKeyDown, and then we write .up. This code here between these two curly braces is run if the up key is held. It's not if it's pressed. If it's just held, then this will happen. And move direction should then be 0 minus 1, because negative y is upwards on the screen. And then we write if rl.IsKeyDown, and then we write down here, which is the down key, and this should be the same as this thing. So we want move direction to be 0,1, and then we need to add in the left key if rl.IsKeyDown.left. Then we write move direction equals -1, 0, because to the left on the screen is negative x axis. And then we finally write if rl.IsKeyDown.right, then write move direction equals 1, 0. So now, if we press F7 to play, we can use the arrow keys to change the direction of where this is traveling on the screen. Let's move on to step 6, multiple body parts. Like I said, currently it's only a head, but we want some kind of tail to follow the snake. So let's add in that tail and make it maybe 3 body parts long initially, and then later we make it grow as you eat food and make the snake longer. So we need some way to store where the body parts of the snake is. And we will do that using an array. So we first need to say how long can the snake be at maximum. And the absolute maximum size the snake could be is if it filled every single square on the screen. That means that the maximum size of the snake is 20 by 20, which is grid width times grid width. So we will say that the max snake length, and we make a new constant here, is grid width times grid width. And then we need some kind of variable to hold this array or list of snake body parts. And we will make that here, and we will call it snake. Because you need an array here, you type max snake length, and then you put vec2i. So this is then an array of coordinates essentially that has the length, max snake length, which will be 20 times 20, which should be 400. So that's the maximum length of it. So one thing you can see here is that this thing here is very similar to this. This is also just an array, but it's hard-coded to be just 2 items. And this one is hard-coded to be 400 items, but store a vector instead of just an integer. And a nice thing in Odin is that as long as 2 arrays have the same size and they contain something that is numerical, then they can be added. That's why we could down here, just to the snakehead position, add the move direction like this without the need for any kind of extra stuff. If you come from C++ or something, you would have needed a vector type with some operator overloading or something, but this uses array programming so that you can just add together 2 arrays that have numerical items inside the array. We also need to store how long the snake currently is. This is the max length. So we will make a separate variable here called snake length, and that will be of type integer. It's just a number that says how many body parts does the snake currently have. And now, since the head will be represented by one of the vectors inside the snake array, we no longer need the snake head position, so we can delete that line. And now we need to set up the snake array so that the head is somewhere, and I also want 2 tail pieces behind the head by default. So we will do that by reusing this code down here, but we will call this one just start head pos, so start head position. And then we can add a colon here so that we actually create a new variable, because this would be a compilation error because there is no variable called startHeadPos yet. But adding this in makes sure that it both creates a variable and also gives it an initial value, but it doesn't know which type this is. So we need to write vec2 integer like that. And now we can initialize the snake array. And I'm gonna make it so that the first item in the snake array is the head. So at snake, and then to set the separate parts of the snake array, you use these numbers within this bracket here. So you can write 0 like that equals start head pos. So the first item at index 0, which I say is the head, will have this position. And then the first tail piece, I want to have a nearby position. So I say the thing at index 1 is start head pos minus 0,1. So that's just 1 above. And then snake piece 2, which is the third one, will have the start head pos minus 0,2. And then finally we need to set this snake length so that it is of the correct value, which is snake length equals 3, because we have 1, 2, 3 pieces in it currently. And in our sketch you can visualize it like this. Down here is the start head position, that's position 10, 10. And this position here, start head pos minus 0,1, is the position here, and then minus 0,2 is this one, so this will be our 3 snake pieces. So our program won't compile yet because we have removed the snake head position, but it's still mentioned down here. So let's start with the drawing code so that we can draw our snake properly, and then we'll add in the code to update it and move the head and then have the body part follow along the head. So in order to draw things, we will use a loop because the snake now has multiple parts, and we will use the same code to draw each part of the snake. So we make a loop just after begin mode 2D here. We can write for I in 0 dot dot less than snake length, and then some curly braces. This is a loop that will run from 0 up to snake length minus 1. So if snake length is currently 3, then it will get, then I will for each lap of this loop first have the value 0, then 1, and then 2. And then we need to take this code here and move it into the loop here. So I will cut it and paste it, and then I will mark this and press tab to fix the indentation. And this currently uses the snake head position, and we can't have that. What we will do instead is use the snake bracket I like this. This will take the position of the current body part we're looking at. And then we will do the same down here, snake bracket I. And this code will now work. We can quickly just remove this line since this line won't compile right now, and then run the game and see if everything is okay. And there you go, you have 3 squares after each other. So let's make them move now. So the way we will make the snake move is by looping over all the body parts and moving them one after another. So we will start by moving the head like this, and then we will move the body part just after it to wherever the head just was, and then the one after that to wherever the body part in front just was. So they just take each other's place one after the other. So inside here, where we are supposed to move the snake when the timer becomes 0 or less, we add a new variable called next part pos, and that's the position the next part after the one we're currently looking at should have. And we set that to the value snake 0. So that's the head's current position. And then we move the head. So we write snake 0 equals snake 0 plus move direction. You can also write this just like this, plus equals like that. And then we loop over the remaining body parts after the head. So we do that using a loop like this, for I in, and now we write 1 dot dot less than snake length. And since we already updated the head here, we do not need to do it. The head is a bit special, as the head moves in the move direction, but the body part will only move to whatever value next part pos has. So what we do here is we write that the current position of this body part is snake I, so that's the current position, and then we say that the snake, the body part at the position I should have the value next part pos, and the next part pos becomes cur pos. So let me explain what all this means. First we save next part pos to be snake 0. That means the position the head is currently on, we put into next part pos. Then we move the head in move direction. Let's say that move direction goes downward. Then it goes like this. Then it goes into this loop, but it skips the head since it starts at 1. And then it takes the current position of this one here, is the one we start at. This is at position 1. It takes the position of that one and saves it in a little temporary variable here. And then it sets the position of this body part to whatever next part pos is. We just set next part pos up here to be the head's old position before we moved it. So this piece will move here. And then next part pos becomes cur pos, which is the value this one had before it moved. And then we can go to the next lap of the loop where I will be 2. So this is 0, 1, 2. So we're at this one then. And here we will just do the same thing. We will move this part to the position this one had before it moved. So this one will move down here. And then that continues for however long the snake is. So that's how that works. Let's now try and run this and see what happens. F7. And now I can use the arrow keys to control the snake and everything is moving around as expected. Currently in the game, if you move off the screen, you do not crash into the side. Usually the rules of Snake is either you wrap around or you crash when you move into the side of the screen. I want it to be so that it's sort of game over if you hit the edge of the screen with the snake's head. So that brings us to step 7, game over on hit wall. So if you hit the wall, then the game is over. We will denote that by having a variable called game over. So just below move direction here, I will make a new variable called game over, and it will be of type bool. Bools can only be true or false, and the default value is false. And I have mentioned this in some other videos, but everything in Odin is initialized to sort of a 0 value by default. Numbers will be 0, vectors will have, like if it's a 2-dimensional vector, then it will have x equals 0, y equals 0, and a bool will be false, since false is sort of associated with the value 0. So what we will do now is add a check if we hit any of the sides of the screen, sort of. And in that case, set game over to true. And then we will handle what happens when game over is true after that. So just after this line here, where we update the snake 0, which is the head, we can just create a little temporary variable that's called headPos, and we set that to snake 0. I'm just doing that to make this code a bit prettier. And then just after this, we will add some logic to check if we hit any of the sides of the screen. So I will write if head pos.x, which is the x part, if that's less than 0. This means that the x coordinate is -1 or smaller, which means it's outside on this side over here, which means that you have crashed. But that's not the only condition. We have 4 different conditions because there's 4 sides to the screen. So we also check if the head position.y is less than 0. That's if the y part of the snake head position is up here somewhere, which also means it crashed. And then we need to check if it's outside on the right or the bottom, and that is or if head pos.x is bigger or equals to grid width. So that means that you're outside here. The grid width is 20. So if you are at 20 or larger, then you're outside because it starts at 0, right? So this column here has x equals 19. X equals 20 is actually already outside. So bigger or equals to grid width is what we want. And then finally we do the same for the y part. Head pos.y is bigger or equal to grid width. Then we put some curly braces, press enter, and if this happens, then it's game over. Currently this game over variable doesn't do anything when it's set. Let's make it so that the game stops when that happens. And the way we do that is by just up here where we update the tick timer, we can check like this. If game over, and here we'll do some nice logic for when the game is over, but if the game is not over yet, then we just write else, some curly braces, and then we can cut this out and paste it into there. So now this tick timer will only update if the game is not over yet. So if we hit F7 to play now, and go around like this, but if we hit a wall, then the worm or snake just stops there. Currently, when you're in this state, there's no way to restart the game yet. You have to manually close the game and open it up again. So let's add so that we can restart the game by pressing the enter key. The way we'll do that is by introducing a new procedure called restart. And when you restart the game, essentially what you want is that all these things that happen here currently happen again, so that the snake starts over in the middle and it gets short again and it gets the original move direction and stuff. So let's do it like this. We write restart : proc like this. So just like main is a procedure, restart is a procedure, and we will be able to use the restart procedure from inside main. So we can cut this stuff out and paste it into here. We also need to update one more variable, which is game over, because when we restart, if game over is true, we want it to be false again. So we write game over equals false here. And now, down here, instead of having all that code there, we can just type restart like that. And then we can go down here to where it says if game over, and then we check if the player pressed enter, then we restart. So we write if rl.IsKeyPressed. IsKeyPressed checks if the key went down this frame, so it only reports true for one frame, and the key we want to check is enter, like that. And in this case we run restart. So now we hit F7 again, and now if we hit the wall, the snake stops, but if we hit enter, it starts over. Currently it's a bit unclear what happens, because when you run into the wall, the game just stops. It doesn't say anything, it doesn't tell you that the game is over and what you need to do in order to restart the game. So let's just add some text on the screen when you are in the game over state that tells you what to do and what happened. We will do that by going to the bottom down here, and just before end mode 2D here, I will write if game over. And if the game is over, then I want to draw some text on the screen, so I'll write rl.drawText. And draw text, the first parameter it wants is what text to draw, and I write here game over. And the second parameter is what's the X position on the screen where you want to put this text. I will say at pixel 4, so it's 4 pixels from the left. Second parameter is Y position, 4 pixels from the top. And then it's the font size. I say 25 pixels high text. And then I say that it should be rl.red, which means we get red color. And then I want some instructions just below this line of what to do to restart the game. So I type rl.drawText, press enter to play again. And this one will also be at the X position 4, but it needs to be slightly lower down so it doesn't cover the game over text. So I would put it at Y position 30, and this makes sense because this one is 4 pixels down, but it has font size 25, so 30 should just be outside of wherever this text is on the screen. And then I want this to be slightly smaller than the game over text, and let's make that text black. So now if you press F7 to play, the game runs, and if you run into the wall, it says game over, press enter to play again. And when you hit enter, it of course disappears since game over becomes false again as we put into restart here. Let's move on to step 8, food that grows snake. So in games like this, you go around with the snake and then there usually appears food at random places. And if your head passes over that food, then your snake grows by 1 square. We will only need there to be 1 food on the screen at a time, so we do not need to store multiple food locations. This means that the food can just be a single vector to I. So we write food pos is a vector to I. So this is the current position of the food, and what we will do here is that whenever the snake eats the food, we instantly just put out new food at a new location. So we just put a new random number into the food position here. Let's first draw the food at the food position, which will initially be at position 0, 0, and then later we'll make it so that the food gets placed at a random location so that you can also eat it. So let's go down here, and just before you draw the snake, which is here, we will draw the food wherever it currently is. So in order to draw the food, we need a rectangle to represent it on the screen. So we'll write food underscore rect here is colon equals rl.rectangle. And it's very similar to this stuff. So we can just actually copy this code here, paste it in here. You can hold shift and press tab to move it back to the correct indentation. The only thing here is that we don't want it to be at any snake position here. We want it to be at foodpos.x and then foodpos.y. And now we can draw this food rectangle with draw rl.draw rectangle rec. And we will put in food rect. And the color will be rl.red. So now if we run the game, we see that there is a red rectangle at the top here, but we cannot currently eat it, and it is currently always just at the top. Let's now make it so that the food is placed on the random position on the screen. We will do this in a new procedure up here. Just before restart, we will make a procedure called place food. So we write place food ::proc, some parentheses and some curly braces. And what we need to write here in place food is some code to figure out a random position on the game board here. But that position is not allowed to include any of the parts of the snake. So it will be a random number where x goes from 0 to 19, so any random number between 0 and 19. And then also for y, there will be any random number between 0 and 19. But we need to exclude the parts of the snake. So the way we'll do this is by first making sort of a temporary grid where we have a 20 by 20 grid and we mark a cell in that grid as having a snake piece there if there's a snake piece there. And then we can later use that to make a list of which of these squares where there currently is no snake part. So in code that means we need a grid that represents which squares in the game are currently occupied by a snake part. So we write occupied, and this thing is of type grid width. So you write a bracket like this, and then you write another bracket like this. Bool. This is a two-dimensional array. This is the size in the x direction, and this is the size in the y direction of it. So this thing would be 20 by 20, so it's essentially 400 bool numbers. All of them will be false by default. So now we just need to loop over our snake and set which of these squares in this grid that currently have a snake part. So we do this by doing a loop that goes for I between 0 and snake length, and then we write occupied at snake I.x, and then we need the y position of it, snake I.y equals true. So this just loops over all the parts of the snake. So in this case, occupied will have everything false except at position 10, 10, it will be true, and at position 10, 9, and at position 10, 8, those will be true. Everything else would have the value false. There's a small typo here, it should be for I in 0 ... snake length. And now we need to build a list of all the cells in the game that currently do not have a snake part in it. So we'll do that by making a new dynamic array called free cells. So we write free cells colon equals make dynamic vec2i. This makes a new dynamic array, and this array up here is fixed size. This one snake here, it cannot be bigger than max snake length. This one can grow to any size as long as you don't run out of memory in your computer. We also will write here as a second parameter context.temp allocator. I will talk a bit more about what this part does later, but essentially this thing here, free cells, starts with nothing in it at all, and then we can add cells to it, and we will make it into a list of all the squares in the grid that do not have a snake part in it. So we write like this, for x in 0 ... grid width, and then this will go from 0 to 19, and it will be for each lap of the loop, it will be in the x variable. And then we write for y in 0 ... less than grid width. So these two loops, inside here you will essentially have access to both x and y, and together they will give you the coordinates of every single square on the game board here. And then you just say if, and then exclamation mark, which means not occupied x, y. And then you can say append free cells vec2i x, y, like this. So this just goes over the whole game board play area, and for each XY combination it checks the occupied grid, and the occupied grid only has true for that combination of x and y if there is a snake part there. So if there is not a snake part there, then that cell is free, so we add it to this dynamic array here, and that's what append does. Append adds new things to the dynamic array and also makes sure to grow it if it is too small to fit another item. So now that we have a list of free cells, we can just pick one cell at random, and that will be the new position for the food. So what we do is we write like this, if len, which means the length of free cells, is bigger than 0, there might be an edge case here where nothing ended up in this, and that's if you have successfully somehow filled the whole screen with snake, which is sort of kind of how you win this game. well, that's the maximum score you can get. So in this if statement, we need to now get a random free cell to use for the food position. So we need to get a random index. So we need to get the position of the thing in the free cells array that we want to use as the food position. So we say random cell index is, and in Raylib there is a handy procedure to get a random value. So we write rl.getRandomValue. So we want the random value between 0, which is the first free cell, and then we want to have the length of free cells minus 1. And after that we can assign food pos to free cells random cell index. This just picks the random cell or square or whatever you want to call it that is at the index, at the number in the position in the array. So and then it sets that to food pos. Right now if we compile this, there will be a compile error, and this is because in Odin this returns a thing of type int, and in Raylib it is of type i32. So what we need to do here is just type i32 parentheses and close in both these things like that. And the reason it is like this is that Raylib is written in C, and in C the standard size for integers is usually 32-bit width, and in Odin it is whatever the CPU you're currently running on has as biggest integer size. My computer is a 64-bit computer, so len would actually return a 64-bit integer, which might not fit into a 32-bit integer. Of course it will do that in this case, but you have to cast that manually to be explicit with what the code does, so that it doesn't do too many assumptions for you. Now we just need to use this place food procedure, and we will put that inside restart. Just under game over, we just run place food, press F7 to run it, and there you see the food ended up down here. If we crash, start over, now it's at a new position. One thing we need to talk quickly about here is this context.tempAllocator thing here. When you type make dynamic something like this, this will ask the operating system for memory. Since it's not a fixed size, it doesn't know when your program is compiling how big this will be. So it will need to sort of, while the program is running, figure out that size and ask the operating system at that point for, hey, can I have some memory? This means that you must at some point also give the operating system back that memory. And this is sort of, some languages have automatic memory management, some have manual memory management, where Odin has manual memory management. So you must manually give back memory that you have gotten from the operating system. Now the call to the make procedure here might not ask the operating system for any memory. It might actually happen down here. Maybe here it just says that this should be a dynamic array of vector 2i, and then down here, when it puts the first thing into it, it might need it to grow from size 0 up to a bigger size. And at that point it will ask the operating system, hey, can I have some memory for this thing? And if it needs to grow again, then it will tell the operating system, hey, have this memory back for how it looked before. I need some new memory that is bigger so I can fit even bigger stuff inside it. That brings us to this context.tempAllocator thing here. If you didn't type this thing here, then you would need to, just after you're done with your free cells down here, manually hand back this memory. So what you could do here is remove that, and then down here write delete free cells. Now this code will also work. When this procedure is done, it will give back this memory to the operating system. If you do not do that, then each time you run place food, the memory usage of your program will go up a tiny bit. You would probably never run out of memory due to this in this simple of a game, but if you had a very intense loop where it constantly allocates memory like this and never gives it back, then your memory usage can grow quite rapidly. But I also wanted to show the temp allocator here for this kind of thing, because I don't care what happens with this memory after this procedure is done, and it's quite nice to not have to write that delete line. And using the temp allocator is nice, especially when you just want to do some stuff within a procedure and then don't care about the memory after that, then you just use it. But the temp allocator is not freed automatically. It doesn't actually hand back the memory to the operating system automatically. What you need to do is at some point in your program, every now and then, just say, hey, can you please empty the temp allocator? Whatever is on there now, just throw it away. I don't care anymore. So in a game, you have a very convenient position to put this. And that is actually at the end of your main loop. So this is my main loop here for blah, blah, blah. So just at the end here, just after end drawing, you can write free all context.temp allocator. So now anything that was allocated using the temp allocator will, after this line, no longer be valid. This means that you can make temporary strings, make temporary arrays and stuff using dynamic memory. If you do not care about that memory after the frame ends, then it's perfect to use the temp allocator, and this free all will take care of all that memory for you. So now that we have the food randomly placed and our memory cleaned up, we need to make it so that the food actually gets eaten when the head passes over it. We will add that code in the inside here where the tick timer becomes less or equal to 0. Just after the loop where we go over all the body parts, we will check if head position equals the food position. And the head position just updated. So if we just moved to the food position, then the snake length should be plus equals 1. So when you end up at the food position, the snake gets 1 longer. So what all this code does essentially now is that it moves the head here, if you're moving downward on the screen, and then it moves this one here, and then it moves this one here. And if this square here had food on it, then the snake should get 1 longer. And since the snake gets 1 longer, we also need to say where should that new last piece of snake be. And it's quite natural, since the head is now here and all the other pieces have moved 1 forward, then the new piece should be wherever the last piece was before it moved. And we're in luck, because next part pos, after this loop is done here, next part pos actually contains the position the last piece of the snake had before it moved. So we can just write snake length -1, because if the snake length is 4, then the index we want to set is 3. Then we set that one to next part pos. And then, since the food has been eaten, we immediately want to place new food. So now, if we run the game and play, and we go here, we eat the food, you see it becomes 1 longer. So now you can really start playing Snake here. Now, one way to lose in Snake, other than hitting the walls of the game, is by hitting yourself. So let's add that in, which is part 9, game over on hit self. So the only thing we need to do here is, in this loop here, just after you set curve pos to the current position of that snake part, we say if curve pos equals head pos, then it's game over. Then of course all this code will continue to run. That's probably fine. You will, in the next frame, end up inside here where the game pauses, and it will show the game over screen. So let's try that. Press F7 to play. Go around with the snake, make it a bit longer before I try to... And now let's hit one more. And then we try to run into ourselves, and we did it. Game over. And then we can press enter to play again. Okay, so let's move to point 10, snake and food graphics. In the description of this video, I have put a zip. The zip is called snakeassets.zip, and it contains a few images and a few sounds that we will put in now here towards the end of this video to make the game look and sound nicer. So when you have downloaded the zip, you have something like this, snake-assets.zip. You open that, and in here you see there's 4 PNG files and 2 WAV files. We can select all that, press Ctrl+C to copy it, and then you go to the folder where your code is, where the snake.odin file is. In my case, it's in C:\code snake, and in here I just paste. So now I have my 4 images plus my 2 sounds. So So let's start with swapping out this red square that represents the food with whatever is inside food.png. And the way we do that is by first loading a texture, which we do like this. We go up here and just under restart here, I type food sprite := rl.load, and there's lots of different load procs, but we take texture, load texture, food.png. So now this will take the food.png from the hard drive, and it's looking in the same directory as the executable. This means that since the snake.exe, which is the output of the Odin compiler, since that is running, it looks next to it and finds food.png, which is this one. So it takes that thing, loads it, and then sends it up to the GPU so that it can efficiently draw it on the screen. So let's use this food sprite texture here now. So we go down here to where we are drawing the food here. We will replace this with drawing this sprite instead. So this code will actually become slightly shorter due to this. We can actually delete this one, food rect, and the draw rectangle rec. And then we write rl.draw texture. And then there's a couple of different draw texture variants. We want draw texture v. And draw texture v, the first parameter is a texture. There we want food sprite. And the second thing it wants is a position on the screen of where to draw the food. This is a vector 2. In Raylib you can have vector 2. These vector 2s use f32, that is decimal numbers, while we use integer numbers here, since we have more sort of a grid layout where things aren't really using decimal numbers in the same sense. So we need to create a vector 2, and we just do like this. We just take two curly braces like this, and this will initialize that vector 2 with whatever we put in here, and we will need to convert the food position.x and then the y as well, food position.y. And also, since this is just, 0, 1, 2, it doesn't take the cell size into account. We need to multiply by cell size afterwards there. And then the last parameter of draw texture v is the tint. If you send in white here, means that it doesn't tint it at all. You can recolor textures by sending in a tint here. And now if we press F7 to play, you see that the food has become a tomato, I guess. It was supposed to be an apple, but whatever I drew came out more like a tomato. So it's the tomato snake. Okay, great. Let's now replace the body part of the snake. So we have here 3 different files. We have head, body, and tail. So the head is the front part, body is all the parts in between, except for the last one, which is the tail. So we will go back up here and also load those. So I will just copy this line and paste it in. So this one will be head sprite. So we change it to head there and head here, and here is body. So we change body sprite, and then we want to load body.png, and then there's the tail sprite. We want to load tail.png. Now let's do something similar to how we draw the food to draw our body parts. So what we need to do here is, in this loop here where we draw all the snake parts, we need to replace this code that just draws rectangles currently with the code that draws the different body parts. So there is 3 different textures which you need to use. So we need to decide which one to use and figure out which body part we're currently looking at. What we can do is we can say here at the top of each lap of this loop, we say part sprite, and we initially assign it to body sprite, which is the one for all the things in between the tail and the head. And then we say if I equals 0. I equals 0 means that we're at the first thing in the snake, which is the head. Then part sprite is head sprite. And then we can type else if, so we check if I equals snake length -1, then part sprite equals tail sprite. So now we have the 3 different cases here, either body, head, or tail, and part sprite will contain the correct sort of sprite or texture or whatever you want to call it. So now we just need to replace this stuff here. So we will write rl.draw texture, and we can use the same one. We will have to replace it eventually because we need to rotate the parts also, but we can start like this. So we write part sprite here, and the position is the same. We can actually, what we can do is we can copy this whole line up here, like this. And instead of food pos, we just write snake I. And here we write snake I. And instead of food sprite, we write part sprite. So now, if we run this, you see something quite funny. So if you're going to the right, then it sort of looks like something with a tail and a face. But as you see, we need to rotate these body parts depending on which direction you are going. So what we need to do here is figure out sort of which direction is each body part currently facing. So if we look at our little illustration here, in this case, if the head is here, then maybe what we want is that the head sort of is facing this direction, and this piece here is facing this direction, and this piece here is facing this direction, and then sort of figure out the rotation everything should have from that. So we can figure out these sort of directions by comparing pieces or parts of the snake to the neighboring part. So we will do that by going here, and just under part sprite I will add dir for direction is a vec2 I. And then if we are at I equals 0, which means that we're at the head, then dir is the current position of the snake part at I, which will be the head, minus the position of the snake part at I plus 1. What this means, if we look at the illustration, is that we take the position of the head, which is here, and from that position we subtract the position of the snake part after it in the list, which will be this one. And when you subtract two vectors like this, then you get a new vector that contains the information of how to get from this position to this position. So we're essentially calculating how to get from this square to this square, which will be a vector that points straight to the right. This vector dir will in that case then have the value 1, 0, which means that in order to get from this square to this square, you have to take one step down the positive x-axis. And we will soon use this direction in combination with a little trigonometry function to figure out the angle we need to rotate the texture. But first we need to figure out the direction for these other cases. So if you are at the tail, then the direction is equal to snake I minus 1 minus snake I. You might have noticed here that this has changed order, and that is just because if we're at tail, then there is nothing behind us, so we need to look forward to figure out the direction, while at the head we can only look backwards because there's nothing in front. And since we are looking backwards here instead of forwards like here, we need to also change the position of where snake eye is on these lines, because in this case we are going from this square to this square, because when you subtract two vectors, you check how do I get from here to here, and in this case you're checking how do I get from this one to this one. And then finally we have all the other body parts in between, and then we can just write else and write that the direction is then it's the same, I minus 1 minus snake I. So this will run in case I is not equal to 0 and I is not equal to the snake length minus 1, which is the last piece. Then it's one of the body parts in between, but we just do the same thing as in the tail case here. Now that you have the direction, you can figure out the angle that you need to rotate the texture by using the 2-argument inverse tangent function. And this function is available inside the Odin math library. So we will include this Odin math library by going to the top here. Just after the RL stuff here, we write import core:math. And when you write like this, then the things in the maths thingy you import here will end up under the name math. What we did up here was that we renamed Raylib to RL so that we could access all the Raylib stuff under RL. But if we had omitted RL here, then you would have had to write Raylib in front of all of the Raylib stuff, which is a bit long, but we can keep this like it is. So now if we go back down here, we can now figure out the angle based on this direction by writing rot, short for rotation, equals math.atan2, and this is the 2-argument inverse tangent function. And this one takes, first it takes the y part and then the x part. So we just write f32 dir.y and then we write f32 dir.x. And this a tan2 procedure is a bit smart and can figure out correctly everything. Even if the y part is 0 or the x part is 0, it will figure out this angle correctly. However, this thing returns a value in radians, and we need a value in degrees since that is what Raylib uses. So in order to convert it, we can just multiply by math.deg per rad, which is just a constant in the math library of how many degrees there is in 1 radian. So now we can try to use this rotation. The draw texture v proc cannot take a rotation, so instead we use rl.drawTexture, and there's a couple of different ones to choose from here. We can start by trying this one, draw texture ex. So we can send in the part sprite and then the position, so we can copy the position from down here. And then it wants the rotation, which is rot, and then it wants a scale. A scale of 1 means no scale, which means it won't be bigger or smaller than it should be, and then it wants a tint. And then we can remove this line here now. And if we now run this, what you will see is something that sort of kinda looks correct, but something is a bit off. This snake is sort of turning in a weird way. What is happening is that it is rotating each body part by the top corner of the body part and not in the middle of the body part. So depending on which direction you are going in, your body part will look like it's not even in the correct place. What this means is if you have a body part that is here and you are going in this direction, then it will look okay. But if you are going, for example, upwards, then it will rotate this body part around this upper left point. So this body part will actually rotate so it ends up here. So it is supposed to be here, just rotated 90 degrees, but instead it ended up here because it rotated 90 degrees around the top left corner of the body part. What we would want instead is for the body part to rotate around the center of itself. So let's try to fix that then. So there is a procedure in Raylib called drawTexturePro, that means drawTextureProject, and that one takes an origin so that we can shift which point it is rotating around. So we will use that drawTexturePro procedure like this. We will delete this line, drawTextureEx, and then here I will write rl.drawTexturePro, and we can just inspect the procedure parameters here. This one wants a texture, and then it wants a rectangle called source, and then it wants another rectangle called dest, and then it wants the origin, and this is the thing we can change in order to change which point it rotates around. Then it wants the rotation, and then it wants a tint. So the big difference here is that this one seems to take 2 rectangles. The source rectangle here is what part of the texture that we are trying to draw do we want to actually draw from. This means that you can take parts, instead of drawing the whole texture, you can take out a small part of it and put that on a screen. That's very nice if you want to do, for example, a sprite sheet animation where you have several pictures of, so for example, a running animation in one picture and you want to swap between them. Then you can use the source rectangle here to only pick a part of the texture, but still keeping them in one image like that. However, in our case, each body part, the head, body and tail, each have their own texture. So we want our source rectangle to represent the whole texture. So we will do that first. We can write in part sprite here, and then we write source : equals rl.rectangle. So if we look, for example, at the texture for the head here, then the source rectangle that contains the whole texture is a rectangle that has x equals 0, y equals 0, and then the width is the full width, and the height is the full height. So we can write that in code like this. The X position of this rectangle is 0, the Y position is 0, and the width of this rectangle is the whole width of part sprite. We can access the size of the sprite like this. So this is an integer, so we need to put it into an F32 because rectangles consist of F32s. So we write part sprite.width, and then the last thing here is the height. So we can write F32 part sprite.height. So now we have a rectangle that tells us to grab everything in this texture. And this is not really part of the problem here, it's just that in order to use Draw Texture Pro, we must supply the source rectangle. So we just put that in there. Now we need the destination rectangle. The destination rectangle is where on the screen do you want to draw this? Within which rectangle do you want to put the texture? And you can use this, since you can put in any rectangle here, you can sort of make it, you can squeeze it and make things longer. However, in our case, we just want to have dest be rl.rectangle, and the position this rectangle should have on the screen is that of the body part we are trying to draw, which is similar to whatever we had here before. So that would be the X position is the snake i.x times cell size, and the Y position is snake i.y times the cell size, and then the size of this destination rectangle is just cell size width, and height is also cell size. So now we can put the destination rectangle in here. Then we need this origin thingy, and like I said, by default the origin is 0, 0. That's the upper left corner of the destination rectangle we're trying to draw into, but we want it to be the middle. So that should be something like, we can use, this is a vector, so we can send in cell size, comma cell size times 0.5. Since cell size is 16, each cell is 16 times 16 pixels, this makes a vector that is 8 by 8 pixels, and its origin thing is relative to the destination rectangle. So this is why 0, 0 means the same position as destination rectangle, and if you put something bigger than 0, 0, then you get it slightly offset from that position. And then we can put in our rotation, rot, and then we put rl.white because we do not want to tint this thing. And now if you press F7, things might look like they're kind of working. There's one tiny thing that's still wrong. You see that the snake is sort of off by half a grid cell. You see how there is a half a grid cell between the snake and the edge there, and you can also be off outside the grid by half a cell. This happens because when you set the origin, you rotate around the center point, but what you're also saying is that whatever position I say that I want to draw my snake part on is now relative to that position. So essentially all our snake parts have been moved upwards and to the left by half a cell size. So the easy fix for this is just actually to add half a cell size to the destination rectangle, and then you're done. So we can add to the X part, we can add 0.5 times cell size, and to the Y part we can add 0.5 times cell size. If we now play the game, everything looks correct. Go around and eat your tomatoes. As a final thing with this graphic stuff here, we loaded a bunch of textures when we start the program. We can, if we want to, go to the bottom and unload them just before we close the window, like this, rl.unload texture. And then we can say head sprite, and we can copy this a few times and just swap this out for food sprite, body sprite, tail sprite. It is good practice to do this because now it will tell the GPU to unload these textures before the program quits. However, when the program quits, it will tell the GPU anyways to release all the memory that this program had used on the GPU for textures and stuff. So it doesn't really matter, but just keeping a clean house and making sure that your program shuts down in a clean way, especially with regards to memory, is, I think, a nice thing to do so it doesn't get chaotic over time. Okay, let's move to point 11, score counter. Usually in Snake, what you do is your score is how long your snake has gotten. That's the score. So let's just add that in there. And this we can do in this way. We can make a new little variable called score, and to that we assign snake length -3, because we set the snake length to be 3 long at the start. So at the start you would then have 0. And for each body part extra you get 1 more score. And then in order to draw this on the screen, we can use rl.drawText. And we see here that drawText wants a string with whatever we want to draw. And I want to type something like score colon and then this number. So what we'll do here is we will actually make a line before this and write score str for string equals. And now we need to go up and include another package from the Odin standard library. So we go up here and we import core fmt. fmt has some procedures to print things to the screen, but it also has some procedures to make new strings out of different variables and stuff that you have. So you can, for example, make a string that says score colon and then a number. So down here then we can write fmt.ctprint, and what we want to write in this thingy here is score colon and then %v, and then I write score. What this thing here does is that it says take this string and swap out %v for the variable score. Just like before with the dynamic array and the fixed size array, since this is something we do not know at compile time, since this number will be of different lengths, it needs to dynamically allocate some memory to hold this string, because this string will be of a unknown amount of letters when the program is compiled, but later when it's running at this point, when it reaches this line or this specific score, it could figure out how big string it needs. So what this procedure here does is that the T here stands for temporary, so this string will be allocated on the temp allocator, which is nice because we are freeing the temp allocator down here, so we do not need to worry about that memory, what happens to it after that. We can just do this and be happy. The F here means format. It just means that there will be this %v and stuff in here that it needs to replace. You might wonder what's the C here. There is a version without the C. The C version creates a C string. Raylib is written in C and it accepts all strings to be C strings. The strings in Odin and the strings in C are not compatible due to C using a null termination, which means a little number at the end of the string that says the string ends here. This just means that it will create a C string so that we can use it right away with Raylib. So now that we have the score string, we can draw it on the screen. Score str, and then we need a position, and a good position is perhaps 4 from the left, just like this one. But instead of drawing it up in the left corner like the game over text, let's just draw it at the bottom, and this will always draw, since it doesn't happen just when it's game over, it always happens. So we say canvas size. Remember, canvas size is the grid size times the cell size. So canvas size then is sort of the bottom of the screen. -14, and then we say that the font size is 10, and this makes sense. Then it will be like 10 pixels high, but it will be 14 from the bottom, so there is a bit of padding below it. And then we say rl.gray. If we now press F7 to run this, you see in the bottom here it says score 0. If I eat a tomato apple, it goes up. And if you crash and die and press enter to start over, then it starts over at 0, because this is not using some extra variable to keep track of the score. It just uses the snake length, which will also reset when the game resets. It's always actually a nice thing to not keep around unnecessarily extra variables. Like, you could have a score counter, but since the score is always related to the length of the snake, you can just take the snake length -3 and then you get your score. No need to keep around an extra score variable that you might forget to zero out when you restart the game or something similar. Okay, so let's move to point 12, which is the last point before the end here. Sound. Like I said, there is 2 wave files here that came along with the graphics, crash and eat. Crash is when you get game over, eat is when you eat a piece of tomato. So we will play those 2 sounds in those 2 situations. But before you play any sound, you must tell Raylib to initialize the audio device. This essentially means that you tell Raylib to set up everything it needs to do in order to be able to play sound. So we go here just below rl.init window, we type rl.init audio device. And just before we close the window, we also need to turn off the audio device or close the audio device. So just here we type rl.close audio device. Now we just need to load a few sounds and play them at appropriate places in the code. So just like we have our load texture stuff here, below it we can load some sounds. So we say it sound equals rl.load sound eat.wave. And then we also want crash sound equals rl.load sound crash.wav. Let's start with the eat sound. The eat sound should be played whenever you eat some food, which is here. So what you do is just after place food, you can write rl.play sound. You see play sound is just a procedure, just wants a single sound. And then you say eat sound like that. And then we need to play the crash sound, the sort of game over sound. Game over can happen in two different places. It can happen here, you crash into a wall, or here you crash into yourself. Let's just add that line twice. So up here rl.play sound crash sound. And then down here again rl.play sound crash sound. Now if we press F7 to play the game, then we can go here and we can go up and eat the tomato. And then if we crash, there is a loud crash sound. You can also check that it works properly whenever you crash into yourself. But in order to do that, you must become a bit longer. Oh, I'm too short. There you go. So that's it. That's how you can create a whole little game using Odin and Raylib that has gameplay, graphics, and sound. Now I also have some ideas for improvements that you're all welcome to try if you want to take this game and make it even nicer. So there's a couple of different things here, and I have posted this list in the description of this video. And all these ideas for improvements have little ratings here of how hard they are to implement. And if you manage to do any of this, then I would be super happy to see what you did. Like you can just comment on here on YouTube, or you can hop onto my Discord server and write in there. There's a link to the Discord server in the description of this video. Before we end, I would like to thank all my supporters on Patreon. These are the people that support me by giving some monthly donations so that I can keep doing these videos. And an extra special thanks to my super supporter Ian Seckington. If you like these videos and want to support me in some way, then you can become a Patreon, or you can, for example, buy my game Cat and Onion. Links to all these things are in the video description. Thank you so much for watching, and happy programming. Bye bye.